One of the things we study with temperature measurement is how to simulate an RTD sensor, a resistive temperature detector sensor, using a resistor network. In this case, we're using a potentiometer and a fixed resistor to simulate an RTD at a temperature of 100 degrees Fahrenheit. And we're measuring that simulated RTD signal resistance using a Rosemount 3144 transmitter hooked up to it using 4 wires, using a 4-wire scheme. This 4-wire connection scheme eliminates the error involved with wire resistance, so we're only measuring the resistance of the RTD, or in this case, of the resistance network. The calculation was done here with an RTD using a simple linear formula with an alpha value of 0.00392, 100 ohms. Base resistance would give you 114.89 ohms at this temperature, 100 degrees Fahrenheit or 37.77 degrees Celsius. The table for the same RTD reads 114.95 ohms. RTDs are not perfectly linear, and that accounts for the discrepancy between the calculated value and what we see in the table. We dial that resistance up on this potentiometer, and it's set up with the system right now, so our control system should read 100 degrees Fahrenheit. So walking over here, we go over to the readout for our Delta V controller, and we're going to see it's reading 100.14 degrees. So we're looking at a 0.14% error on this particular measurement system. Each student in the team has to simulate an RTD with a potentiometer, showing that they understand the correspondence between resistance, the number of ohms, and the number of degrees, and they know how to use the formula and the chart, and show me, of course, that their system actually does read accurately, so they have to get all the connections right. Then later on, we will configure this transmitter for thermocouple input instead of RTD, and do the same thing again, simulating thermocouple using a voltage divider network and a DC power supply.